Hi, my name is Jason Teachart, founder of SMT Research, and today I'm going to talk to you about mass timber monitoring, basically risks from moisture intrusion and other items that we can monitor during construction. In general, SMT has been known for quality assurance of roof membranes on traditional concrete and metal construction, in which we're doing quality assurance of scanning membranes during construction, installing passive sensors embedded within the roofing system in order to come back and be able to inspect those membranes after the overburden or the green roof has been put in place, or ultimately getting the data up to our cloud-based analytics system that enable us to take trends and readings as to how that roof is performing over long term. Classically, what we've been finding is on these types of solutions is that the roof membrane is typically well done by waterproofers, but it's the construction sequencing or damage by others that occurs on the sites, whether it be staging materials, putting forming nails into your project. These are typically what we're finding as damage that happens on every site to horizontal membranes. Similarly, for mass timber buildings, they're built in the environment in which it's rainy, wet, and environmental conditions do prevail, even though they may be submitted as a prefab construction in a dry environment. SMT will get these drawings from architects and designers saying, hey, I'm really quite concerned about this detail. We have a mass timber building, which doesn't allow any air vapor movement to dry to the interior. And I may have a solar or green roof asset placed on top of this roof. How do I monitor this? That we're going to go forwards with a really dry roof and a really robust system. So SMT has three solutions for mass timber monitoring. The first of which is a conventional roof monitoring system, in which we embed detection strips right within the conventional roof. The second one is monitoring the actual mass timber structure itself in basically in a grid-like fashion. And a third solution is monitoring critical structural components in a less intensive way to basically understand what's going on at that particular detail. Conventional roof assembly, these moisture detection strips would go in down on the air vapor retarder underneath the insulation, do perimeters and penetrations, and we're able to get what the moisture level is within this particular structure. A sample of the output, once it's gone through data acquisition and through our visualization tools, is shown here. The red areas are considered a wet detection strips, and we start comparing different timelines, different building components, and we can point to the areas where water has intruded within the conventional roof assembly. And we have tools that not only look at it in a virtual reality model, but also we have an augmented reality tools that enable you to walk on the construction site and have a look at the real live sensor data of what's happening below the membrane or below the green roof, either in real time from that point in time, or go back and historically have a look at what may have happened during construction. These tools enable you to go out and do assessments, either remotely in virtual reality, or go out and help a technician find out where a leak may be. The second part of this solution is monitoring the actual wood structure itself. And if you're going into a rooftop assembly, you can go in through the air vapor retarder, make a small opening, obviously do a repair, but put these moisture probes at depth within the structure. Alternatively, as pictured on the right-hand side, we can do these from the interior, depending on internal finishes and routing of various sensor elements. A lot of these sensors will put in a grid-like fashion, pick a density that would also maybe correlate to the details within the building, and then ultimately report back in live real time as to how the building is taking on moisture and if it's critical to that particular mass timber element. This is an example of solution 3, where we basically went and monitored not the whole roof, but an eyebrow cantilevered section of nail lamb timber, which had a propensity basically to collect moisture in it. And here you'll see the graph in real time, and the top section of this graph is 19% wood moisture content equivalent. And you'll see that seasonally this water does get wet and does dry out currently. We are going into our third season of monitoring, and these will be notified to clients as to how it is performing over the long term. We also have other projects where we don't necessarily have actively monitored sensors in, but we'll take a project that has got wet during construction, install these same moisture probes, and take readings with a simple multimeter or a moisture meter on a junction box, and leave these sensors within place in a number of locations within the building while it has been enclosed up. We'll leave these sensors at a junction box that will enable us to come back and take a reading at a later date. So you could take a yearly readings, but you're only going to get 1 or 2 data points over each year unless you're continuously taking readings. A number of other services that we do with mass timber industry is do mock-up testing, validation of all sorts of different building science parameters. We work with projects like Brock Commons on floor-to-floor compression, monitoring the difference between the wood element versus the hybrid concrete stairwell, watching to see how much movement occurs over the construction period as well as long-term. And on the right-hand side, monitoring post-tension shear walls that are done in mass timber to look at their movement again over short periods of time as well as long-term. Ultimately, we get involved in all types of projects, from single-story buildings to some of the tallest in the world, and I've been doing this for 10 plus years. So this is not a new industry for SMT in order to take on monitoring of different types of mass timber structures. We welcome you to contact us to join us in an AIA approved continuing education on mass timber monitoring. But ultimately, you're welcome to contact us at any of the information there below, and one of us would be more than happy to talk to you about your next project. Thanks a lot, and have a great rest of the symposium.